All right, welcome everybody to the second day of CSI 41. We are going to continue our discussion of reviewing CSI 40 today, and by continue I mean really start it. We didn't do very much on the last class, and so the goal for today is I'm not going to do a comprehensive overview of C++ because I've been looking at your test results on Canvas, and a lot of the questions you're getting right. And so I'm not going to bother going over variables and things like that. However, any question where like a quarter or more of the students got a question wrong, I think I'm going to talk about that today and see if we can clean up some confusion or gaps, or maybe you just never seen a vector before. You know, it just really depends on your professor. So where is Putty? I've got 3 screens now. These things are, there we go. These hide for us. So, you guys are all on the server. You guys have any issues connecting to the server?
Hey, Coney, you're not streaming.
I'm not streaming. Oh, well, that's something I should probably fix. I thought I hit screen 3. Weird. Okay, there we go. How about now? You guys see that now? You guys good? You didn't miss anything. It was just me staring at a background. All right. So let's talk. Let's talk about this stuff. So, let's make a little bit of code here. And the first thing I noticed was this. Okay. So if you have just a variable by itself, this could be an integer, it could be a float, doesn't really matter. If you just have it by itself with no comparison operator, then what it's doing is that it's just using the value of the variable itself to determine if the conditional is true or false. So the rule is in C++, 0 is false, everything else is true. Okay, so if you have something like that, this is false because x is 0. Okay, so cout a inline else cout b. Okay. So if we run this code, it's going to output b. Okay. And if x was 0.1 or negative 0.1, it doesn't matter. If it's anything but 0, then it's going to output a. Okay. So that's a little bit of C++ trivia, still fairly important to know, especially because in CSI 41 we're going to be using this syntax a lot with pointers. So when a pointer is null, it's 0, and so we'll say if pointer, and that's saying if the pointer is not null, right? Because 0 is false, null is false, null is 0. Okay, so this shorthand here is something we're actually going to be using a lot in this semester. Also, if you're a Java programmer, if you came from a Java background, you can't do this, which bugs me. It actually bugs me. You can't do this in Java. You have to say if x is not equal to 0. You have to type the whole thing out. And this here is, of course, it's the same thing. Like that and that is the same thing, right? So, okay, that, right, and that, same thing. Java as a language bugs you? Sort of. But there's some things that Java does right and some things that Java does wrong. And so whenever Java made a good design decision, I tend to highlight it. Because Java really is C++, but different. Like they took C++, the core language is the same, if statements and for loops, and like all that stuff's the same, and then they just kind of changed some of it. Yep. So, and some of the changes they made were good. So, give credit where credit is due. LS. You want me to talk about LS, Minkrelli? I got a lot of files in here. I need to clean this up. My lord. Okay. Let's just clear the screen and pretend we didn't see that. So, Minkrelli also posted a video tutorial, which is up on Discord and on Canvas, which talks about Unix and Vim. So if you've never used Unix or Vim before, or if you have basic level proficiency it's well worth the watch. I watched it last night. It's excellent. He talked for about, I don't know, was it half an hour or so? What is the clear screen command? Control L is clear screen. So I hit Control L to clear the screen. Or if you want, you can type clear. Or if you want, I have an alias set up to clear. Because in DOS, CLS clears the screen. And so whenever I used to use DOS and Unix at the same time, and I always preferred the command that had less typing, right? Like on DOS, like there's a command to get the IP address. It's shorter than the Linux version of it. So I typically alias down to whatever's smaller. Can't watch the stream; it's full. Yeah, McCurley, can you do the echoing thing? CLS. Yeah, CLS is technically not a Unix command. It's clear. Clear is the Unix command. CLS is a Kearney special alias that is just on your account. All right, I'm in Curly's streaming now. Excellent. Cool. All right. Yeah. So alias CLS. It's an alias for clear. All right. It's now doing the thing again. The thing gets hidden. Let me pull that back up. Do the projector. Nope. Seriously. Always on top is set. It's so stupid when it does that. It's fine. We don't need the whole screen over here anyway. All right. So the next thing I want to talk about was the call by reference, call by value, call by const reference things. So when we do a function, there's a choice you have to make, and that choice is what, like if you're going to take a function that takes an int, you know it's going to take an int. Like you're making a function like add. You know, an add takes, I don't even know why you write an add function. It takes 2 parameters and, you know, returns x plus 1. No. There's absolutely no reason to write this, but let's say you're writing this. Even when you know what the parameters should be, you know the return type should be integer, you know the parameters should be integer, there's still a choice you have to make, which is, are these parameters going to be const or not? And are they going to be called by value or called by reference? And that's a decision you make every time you do a function call. Now, there is a general rule of thumb. The general rule of thumb is this. Primitive types, which are the things built into the language, int, float, double, are call by value by default. And everything else is call by const reference by default. Like if you tell me nothing else about, you know, a function, if you're like it's just gonna take 2 strings and return a string that's the sum of the 2 strings, those strings are going to be const reference by default. Like that's just the rule of thumb, and it's not hard and fast. Like if you need it to be different, you do the different thing. But like these are the defaults. It's not 100%. It's just where you start with, right? So if I'm going to be taking in 2 ints like this, they're going to be called by value. There's no reason, especially for this function, to make it call by reference, right? Y is not changing. So if I ever see a parameter that's called by reference like this, not const reference, just called by reference, you're telling me without using words, you're telling me using code that Y is going to change. Right? And, you know, for something like this, like I can just look at it and be like, okay, Y is not going to change. Why the hell is it called by reference? Doesn't make any sense. But in real life, what happens is you have a situation like this, where you've got like, you know, 10,000 lines. I literally just made, yeah. And you're scrolling through it, and nobody's got time for that, right? So what you do when you're a person, and you're using this function, you're a person, and somebody's like, hey, I made this function, it does this cool stuff. It's not called add anymore, it's, I don't know, Zeta, right? I made this function, and it's doing like all this like cool, weird stuff. I don't know what it's doing. if I look at just the header, like just the prototype, just the signature of the function, if I look at it and I see that something is called by reference, you're telling me that you're going to change y. This is what you're telling me without using English. You're telling me using code. Y is going to change somewhere in this function. We're going to be changing the value of y, and whatever value you pass in to y from main is going to get mutated. It's going to get changed. Okay? And yeah, that's what it means. Like that's the connotation of it. So if y is not going to change, then you use const, right? Like const means this value is not going to change. Now, in this case where it's an int, I wouldn't use call by reference at all. I'd use call by value. Okay, and the reason for that is because if it's not going to change, then why pass it by reference? Because let's get a little bit technical here. When you call by value, call by value really should be called call by copy. You are making a copy of the variable. You're cloning it, you're duplicating it, and you're passing the duplicate to the function. And for an integer, that's not a big deal, right? It's actually faster to pass an integer by value than it is to pass it by reference, because the reference is 64 bits and it's 32 bits. It takes less RAM. And moreover, when you pass something by reference, you're passing a pointer. You're passing a memory address. And so you have to pass it, then you have to dereference it. And so it's actually slower to pass an integer by reference than it is by value. So I would just write the function like this. Or if I really wanted to be, technical, I could say these are const, It doesn't matter, because who cares if the duplicates change? But, maybe it's probably a good idea to. If something doesn't change, if a variable never changes, mark it as const, right? Like there's a philosophy called const everywhere. It's like this variable x here doesn't change anywhere, mark it as const. And the reason why we do that is twofold. First of all, if you do change it by accident, which happens sometimes, not in simple cases like this, but maybe you pass it to a function and that function changes it, and you weren't aware of that, it'll find it. It'll actually flag it as an error. Hey, you told me this thing should never change, and it's changing. You're like, oh my goodness, you're right. Yeah, I didn't know that function changed the variable. No, thank you. So that's one. First of all, when you mark something as const, the compiler will help you and be like, oh, you screwed up. You told me this thing couldn't change, but you're saying x, right? You told me it's not going to change. This is trying to change it. What? Oh, shoot, you're right. So it helps you. Two, it's an optimization thing also. When things are flagged as const, there's a number of optimizations that turn on that aren't possible when the variable can change. And it really depends, because optimizers are quite smart, and so, whether or not you actually get a performance gain out of it just depends, on how smart the optimizer is. But it's quite possible that for a regular variable, at some point it's going to be like, all right, I'm not going to need you for a while, write it to RAM, and then later on when it needs it again, it reads it from RAM. And reading and writing to RAM is slow. Like we think of RAM as fast, it's not. It's actually really slow. And if it's const, you know that it can't change anywhere within the function. And so whatever value it had originally, we'll just use that again. And we don't have to read and write to RAM. If it's 42, we'll just put a 42 in there. We do what's called constant value propagation, where if we know that x is always negative 0.1, then rather than reading and writing negative 0.1 to RAM over and over again, we'll just, like 1,000 lines below, if we use x again, we're like, oh, that's negative 0.1, and we just put the value in there. We don't need to. It can actually give you quite a nice speed up. You guys feel me on this? Like, when it's not marked as const, then sometimes the optimizer can't figure out if it's going to change or not, and then it has to do reads and writes when there's absolutely no reason to do so. What if you call by value for an int instead of by reference when it's going to change by a function call? Yeah, if it's called by value, who cares, right? Because this is a doppelganger, right? Like we're going to say x is equal to 5. It's fine. I don't know why you'd pass it as a parameter, but it's fine. It's doable. Sometimes we do that, just like for x is greater than 0, x minus minus. We sometimes do that, right? So you take a parameter and then you decay it down to 0, and do stuff with it. Yeah, it's fine. It's valid code. Looks crazy, right? It's perfectly valid C++. You can do that, sure. With call by value, it's a duplicate, so you don't have to worry about the original value back in main changing. The big thing, though, the most important thing, is when you pass in something that's not a primitive, right? So if you pass in a string, call it string concat. If you pass in a string, and let's say it's just going to glue the two strings together, right? Something simple. So you pass in a string and a string, and it glues them together. If you pass in hello and world, it turns them into hello world, and then it returns hello world. No, I said it like that deliberately. There's no space. Hello world, hello world. Okay. If you want a space between them, there you go. Hello world. This is bad code. You should not write code like this. A lot of people do. And the reason why people write code like this is because they think of call by value as the default, right? The call by value is just normally how you write a function. Now, here's the rules. Right? There's two rules. Right? There's two rules for defaults. For primitive, call by value. For non-primitives, for class types, for container types, like vectors and things like that, don't pass them by value by default. Are you guys with me on this? You guys understand? The reason for that is you're duplicating them. So if you're passing in Hamlet for A and you're passing in Othello for B, it's going to clone Hamlet. It's like every time you pass something by value, call by value is call by copy. It clones the value. And so if you're passing in 100,000 words, it's going to make a copy of all 100,000 words for A, and then it's going to clone B, and then it throws them away. There's absolutely no reason to have done that. Just every time you call the code, it's going to freeze for a second, when there's no reason to. And this is probably one of the most common mistakes that I see new programmers make, is that they'll just always use call by value because they didn't understand call by reference, or it was confusing. The ampersands look scary. I hear it's like a pointer under the hood, and pointers are scary, so I don't want to mess with them. So that's why the Java language actually made this rule the rule. So it's not just advice. In C++, this is just good advice. In Java, it's the rule. Primitives are passed by value. Everything else is passed by reference. And the reason why they do that is because then you don't need an ampersand. In Java, they do call by reference, and they do have pointers and things like that. They just don't have any stars, and they don't have any ampersands because those are scary. So they just got rid of that and just made it look all nice and like a regular variable. But under the hood, it's actually called by reference. It just looks like a regular variable getting passed in, but it's called by reference. If you were to change it, if you were going to set b equal to high, in Java, this would actually modify, the thing out here. Okay. So in C++, this does not modify S2, because this is call by value. Call by value makes a clone. It's going to clone S2. It's going to duplicate it. It's going to make a new string out of the duplicates, and then the duplicates get thrown away. So if we got S1 and S2, you will see that they are not changed, because we're doing call by value right now, right? Okay. But if we did call by reference, which you should use call by reference anytime you have a string, because then it doesn't duplicate the string every time. All right. The only time you do call by value with a string is when you actually want it duplicated. When, for whatever reason, if you want a copy of Hamlet, you want the original Hamlet and you want Hamlet 2.0, then you do call by value. And so now you can see, because it's call by reference, here, you guys remember the code? Here, B was changing, but it doesn't change it back in main. Here, B changes and it changes it back in main. Okay. So for a function like string concat, I would not expect A and B to change. That would be a very bizarre and very odd thing to see, right? Because I'm passing you two strings and you're going to glue them and return the result. It would be, I would not expect that to change A or B. But if I was looking at, and in fact, this is probably how the code would be, right? But if all I had to go on was this prototype, you're telling me, again, you're telling me through code, not through words, you're telling me through your code that A and B are going to get modified. Okay? That's why we use const reference by default. So for strings, we use const reference by default. And for primitives, we use call by value by default. Okay? And so now if I look at this, you know, I'm using your code and I look at this function prototype, I'm like, okay, A and B are not going to change. Thank you. That's all I wanted to know. If I pass my stuff to you, are you going to chop the arms and the legs off? You know, is it going to come back to me unharmed? Or are you modifying it? Are you mutating? Or is it going to come back with like tumors all over? You know, that's why we put const on there, so that you're it's like documentation. It's like you're telling the person using your code, A and B aren't going to change. Don't worry about it. We do reference for speed, and we do const to tell you it's not going to change, and also to protect us from accidentally changing. So if we did accidentally, you know, something like that, it would flag it. Nope. Okay, it's really important. It's really important. Java is like the polished version of C++. No, definitely not. It's an offshoot of C++. The language itself has issues, like you can't do this in Java, right? So, Java is it's more verbose, like it requires a lot more typing, and they love themselves some object-oriented programming. They love themselves inheritance and things like that. I'm not a fan of inheritance. I'll use it when it's appropriate, but Java loves inheritance, and that causes issues because in general, inheritance is a bad idea. That's my thesis. It's a hill I'll die on. There are times when it's appropriate, but in general, inheritance is just a bad idea. Sorry, Professor Savage. I mean, he's dead now. He just died earlier. But the professor who taught me loved inheritance. Yep. Can you go over what the X alone and if statement does again? Yeah, remember X is, this is saying if X, right? And so what is true, what is false? False is 0. True is everything else. So this is if true, right? If that is if true. Okay, it'll print out A. That will print out B. Okay. If you don't have any comparison in there, it's just checking to see if the value is 0 or not. Okay. What is inheritance? Inheritance is when you have one class derived from another class. We'll talk about it in this semester. We talked about it a little bit last semester, but it's when, like, if you write a class, you can make another class that inherits from it, and then all the code gets copied over without you having to retype it. So there's times when that's actually really nice and really useful. Most of the time, though, it's a bad idea, so, in my opinion. Not always. Most of the time. Okay. Call by reference if you want it to change in main. Yeah. So if you wrote this would be telling me A is going to change. So if I pass S1 here to string concat, I'm, without looking at the code at all, just by looking at the prototype, you're telling me S1 is going to change. Okay, that's what you're telling me if you write your function that way. That's why we do const reference by default. Okay. It's fast, it's safe. Right. Is there ever a reason to make the function parameters change, or is it just bad practice? No, it depends what you need. There's no there's no like, that's why these are defaults, not 100% rules. You know, they're just defaults. So like if I wanted to make an uppercase function, which should be part of the standard library, don't know why it's not, but it should be. If I want to turn S into an uppercase version of S, then like that, then we're modifying S, right? So if we do that and we say uppercaseify S1 like that, then that's going to turn S1 from hello into hello. Okay. So yeah, call by reference is fine. Sometimes you want to modify your parameter. It's fine. You typically you'll typically do documentation where you're like S is getting modified. You know, like you'll usually like you know, write a better comment than that, but you'll usually make some sort of note in the function header saying like what each parameter does, and if they're getting modified, like what it's going to get changed to, and things like that. It's good documentation practice. If uppercaseify was in standard, would it be C strings or strings? I don't think they modified the C string stuff at all. I think they've left all that basically untouched from C. But, you know, Python has a .upper function. Like, that seems useful to me. I don't know. You know, like, given how often people uppercase things, like, it seems like it's not hard to write, you know, and it saves people time. I don't know. They're more interested in adding in just weird stuff, I think. Let's see here. 2 books. Append the 2 books together. Okay. Yeah, if X is already declared, that's why I had that just semicolon at the beginning, because it was the parameter, right? So it was defined already. I didn't need to declare it again. JavaScript has 2 uppercase and 2 local uppercase. Oh, nice. Yeah. Nice. Yeah. I don't know. It just seems like one of those things that should be part of the standard, but it's not. So here's a function to uppercase it. Now, this is a good time to talk about range-based for loops. So a lot of people didn't know range-based for loops either, looking at the test results. So this is your standard loop for looping over a string or looping over a vector. So you start at index 0, you go to the end, 1 letter at a time, and you set that letter to be the uppercase version of that letter. Okay. If you wanted, you could do this with square brackets. In general, I don't recommend new programmers use square brackets because it doesn't do bounds checking. So which means that if you go out of range, if you screw up and you say I plus 1 or something like that, that's going to go off the edge of the string, and it's bad. Like where you're at right now, you should always use .at instead of square brackets. And if you ever need to speed something up, in a case like this where it's kind of bounds checking already, like this is pretty solid, and I don't have any plus 1s or minus 1s in here. Square brackets okay, like you'll get a pass from me if I did a code review, like that's fine, you know. No need to do an unnecessary bounds check when you're bounds checking already. But in general, for where you're at right now, just always use .at, and you can thank me later, because like these bugs are the most annoying in the world to solve, because if you go out of bounds and if you're C-outing something, it's not a big deal. You're gonna get some garbage or whatever. It's not a big deal. But it's really dangerous when you're writing. When you're writing to RAM. If I did something like this, I'm writing 10 letters past the current one. Oops, not .at. Okay. And so by the time it gets to the end of the string, it's going to be overriding memory. Whatever's in RAM past the end of the string. And who knows what's there? Nobody knows. You're just corrupting it. Right? It might crash, might not crash. If it doesn't crash, that's the worst. Because now you've overridden RAM, and that RAM might be important. It might be your bank account balance, it might be your social security number, it might be the pointer to the start of another string that you've just corrupted because you've overridden it. And the code runs fine, and then an hour later, when you finally get around to see-outing that string there, it crashes your code. And you have absolutely no idea why your code crashed. Because it was corrupted an hour ago. And you go to see-out it, and it's like, boom, seg fault. And your code will just start randomly crashing, and it is so frustrating. It is so frustrating to find those bugs. And even if you do track it down, oh, it's a problem with this string right here. This string here, I'm see-outing hello world, and it's crashing. Why? Why is hello world crashing? This makes no sense to me. And it's because your code there is fine. That code is fine. It's the code here. It's the code here that is corrupting the memory. Those are 100% the worst bugs in existence to deal with. Okay. So, the new C++ version comes out in 23. I don't know how much is in there. They promised reflection. Reflection's not going to be in there. Networking, I don't expect networking to be in there, maybe, but I don't kind of think so. Will .at solve it? Yeah. So if you use .at, it won't solve your bugginess here, right? Like this is still a bug. This is still going out of memory, or it's going out of let's make it really obvious here. It's trying to write to memory, not in the string. It's still a bug, but with .at Montoya, it will kill your program, which is good. It'll kill your program. It'll say, hey, you tried accessing element 1010, and the string's only 10 letters long. No, you can't do that. And you're like, oh, thank you. And it'll tell you, here, that's your mistake right there. And then you fix it. Not a big deal. Right? Not a big deal. And so square brackets are highly toxic and hazardous. I don't mean toxic like, League of Legends forum toxic. I mean, like, literally, it's like you're leaving barrels of toxic waste. You got to be real careful with them. Like, if you know how to handle them, you know how to put on the gloves and the radiation suit, like, okay, okay, it's fine. It's one thing. But by default, just don't. Just leave it. Just leave it. Nothing you're going to need anytime soon will require that level of speed for square brackets. Okay, safe and slow to begin with, and then if you really need speed, go fast. Okay, that's the rule. Okay. All right. So let's talk about range-based for loops. So rather than doing this, the way I would write this code is this: for every character in the string, that character is equal to the uppercase version of that character. Okay? So for every character in the string, and I'm using the reference there because I'm changing it, right? This is the same as call by reference. If I made this const reference, it would complain, right? Because I'm changing it. Okay. So this can be called by value. That's going to make a duplicate. This is going to make a duplicate of every character in the string. And the duplicate's going to get uppercase, then thrown away, which has no point whatsoever. I do this all the time. Like I screw up and why is my uppercase function not working? Got to be by reference, so you can actually change it. And this is going to say for each. It's a for each loop. For each character in the string, set that character to be the uppercase version of the character. And this is a lot faster to write. It's less typing. It's easier to read. This is like way more complicated. It's got square brackets in there, which make me nervous. Because remember, square brackets are like toxic waste barrels. Like, if you know what you're doing, you can handle them. But like, if I see that in some student's code, I sit there and I stare at it. It's like in, I don't know, one of those movies where like the mean father meets the daughter's boyfriend for the first time. He's just like staring at him like, are you on the up and up? That's my reaction towards square brackets, okay? I always forget the ampersand in the range-based for loop the first time. Yeah, everyone does it, but but I don't need to, right? I don't need to because I'm using a range-based for loop. Yeah. Range-based for loops start at the beginning and they go to the end. The only time I use a regular for loop like this is if I'm not going to go across the entire container, or if I need to know what I is for some reason. Like if I'm setting it to like, if I am setting the first element in the array to 0, the second element to 1, the third element to 2. If I need something like that, then you have to use a regular for loop. But but most of the time when I work with a vector and I'm just messing with a vector, I am just going to mess with the entire vector, print out the entire vector. It's very common, right? Not always. Like sometimes you want to print out a slice of a vector or something. It happens. There's nothing wrong with a for loop, But anytime you want to do something across the entire vector, then I use a range-based for loop. Okay. Any questions? A lot of people haven't seen range-based for loops before. If you hadn't had me for 40, but they're nice. They're real nice. It's the same code. No. Was the same code. There we go. So this line here is doing the exact same thing as this here. No index. That's nice. You can't go out of bounds if there's no bounds to go out of. You know what I mean? Is range-based faster? No. I benchmarked them. They're the same speed. If you turn the optimizer on. With the optimizer off, they could be slower. But with the optimizer turned on, which is the only time you should be benchmarking anyway. Like, you shouldn't be benchmarking anything with the optimizer off. That's why. Why would you do that? Unoptimized code is terrible, by the way. With the optimizer on, it's the same speed. Faster to write, sure, absolutely. And that's something to optimize for. And that's something that I think a lot of people don't pay enough attention to, which is optimizing your time. If it's going to take you 3 years to write something, or if it's going to take you 3 minutes to write something, it's a pretty big difference. Who cares if the 3-year one is 10% faster? Yeah, okay. So, how would you print it out? Like that. You can't do this, right? You can't do that because uppercaseifies a void function. Void functions do not return a value. So basically you uppercaseify the string and then you see out the uppercase string. So it turns into hello. Okay. One other thing I forgot to mention earlier with this thing here. If x or y, about a quarter of you hadn't seen this before. The C++ 11 standard, I believe, added and or and some other English words as well. Mostly for people who didn't have the keys on their keyboard, I think. I think the reason for that was because not everybody has vertical slash characters that are easy to access. There's a lot of weird keyboards out there. Like, if you ever travel to, like, France, it's almost the same as the QWERTY keyboard, but, like, a couple of the letters are, like, in the wrong place. It's so weird, like, to use, because you're just typing, and then the letter comes out wrong. You're like, well, and so I think that's why they introduced it, but I prefer it for two reasons. First of all, it's actually more readable to me, like, X or Y. Whereas, when you have all these, like, ands and ors and everything like that, like, after a while, it's like, And the other reason, the main reason why I do it, is because there are bitwise and or operations that are a single line. See how that doesn't compile? That compiles, but the single one doesn't, right? And they're different. There's and, which compiles. There's single, which doesn't. And so it's just there to have me avoid screwing up. Okay. So sometimes I will type a single ampersand instead of a double ampersand, and if you do something like that, now you're talking about a reference. You're getting the address of y, and so I just write and I write or to just eliminate that possibility. You learned using and, or, and not in your CSci 40 class? Using symbols or using English? Luis Limas, English, yeah. Yeah, it's been around. I think most professional programmers still use, they prefer the double ampersand or whatever. And that's fine. So, if you wrote code like that, I'm not going to say anything about it. It's standard practice, but I consider and like probably a little bit more readable. Okay. All right, so let's look at more of your test results here. McRelly, is there anything else that we talked about in the previous section that we should mention here?
Trying to think right now. We did talk a little bit more about vectors and arrays.
That's right. Yeah, absolutely. So there was a question about the difference between arrays, vectors, and C++ arrays. So yeah, let's do that. I'll just wipe all that. Who cares? Okay. So if you wanted to make 100 integers all at once, then let's see. Anything else in here? Oh yeah, while forgot about that one. Okay, question for those of you on Discord chat: how many times is this going to print "Hello World"? You prefer double ampersand and double vertical slash due to nostalgia? Yeah, it's fine. Like I said, I don't really have any strong preferences on it. I try to code in a way where I don't write bugs, and occasionally I will say if x and y, and I write x ampersand y, right? Because just my English brain, It's like in the earlier class, I was saying the word 7, and I was trying to write the word 4, and I wrote 7 because I was looking at a 7 and saying 7 and trying to write 4, but the 7 came out, And so to avoid bugs like that, I've kind of switched to using and or, but it's not hard and fast. It is not an infinite loop. It is 0 times. So 0 is false. Remember? So 0 is false. And so if you have a false thing between the parentheses, it will not execute. Everything else is true, right? So if we set this to be 5, how many times is this going to print out "Hello World"? Infinite. Yeah. It's going to print out "Hello World." It's going to check to see if 5 is still true. 5 is still true. It prints out "Hello World" again. Checks to see if 5 is true. It's still true. It never changes. So yeah, it's an infinite loop. 5 is true, as is all non-zero numbers. Okay, good. All right. So yeah, McRelly, let's talk about vectors and also maybe arrays a little bit. All right. So difference between vectors and arrays. A lot of professors only teach arrays. You don't need brackets after. Yeah. Okay. So let's talk about that too. If true, scout high, valid C++. Brackets are used if you're going to, they're optional. It's not like you can't use them. Right? That's valid C++. But if you're going to have 2 lines, you have to have a bracket. But if you're only having 1 line of code, like this, brackets are optional. Okay. technically, if we'll launch the next code block following it. And a code block can either be a single statement or it can be a curly brace block of code. Okay. So you can either do it with or without. Some style guidelines will enforce always having curly braces. That's a fairly common style rule to follow to avoid bugs. Kind of bugs me though, like especially for something like I don't know. Yeah, if I'm doing something like this, like I don't want to write out, you know, like it, you know, like you're making me take up 3 vertical lines and indent and have curly braces, like for something really small and short like that. Like this looks better to me. I don't know. I'm probably in the minority here, but it's one of those things. Like people will argue about style forever. Just be aware that whenever you go to work for a company, they will have a style manual that you will follow. So, whatever they say is correct. Why are you Kearney? That's funny. That's hilarious. Avoid bugs within the code, but bugs the coder. As long as it's small, the no braces. Yeah, that's kind of my take on it. Like if I'm gonna do something like I don't know, something like really big like that, you know, I'm gonna put curly braces on it. You know, even if it's one line of code, it's still probably gonna have curly braces. Just you know, so style's a weird thing to talk about, but yeah, the new reaction GIF. Yeah. Okay. All right. It's array int r100. So, oh yeah, and also this. Okay. The equals curly brace thing is added in modern C++ also, and that means initialize the array to all zeros. Really nice. Back in the day, every time we made an array, we would immediately follow the array with a for loop to initialize all the elements in the array to 0. And you know, you make like a 3D array, and then you have a triply nested for loop, and it's just like it was like this really annoying boilerplate that every time you made an array, you're like, oh Lord, and you just make a for loop and a triply nested for loops, and you're like, oh goodness. For n yeah, no, nice. Okay, so this makes 100 integers from r square bracket 0 to r square bracket. What's the last one? What's the last index? 99. Yeah. Mm-hmm. Okay. So not 100. That's a common mistake too. If we wanted to use vectors instead, the syntax is this. Okay. And then the C++ array way of doing it is saying an array of integers of size 100 named R2, I guess. And this also makes 100 integers. Now, what's the difference between these 3 options? We've got the C style. This is a C style array. This is a vector. And this is a C++ style array. All right, so let me break it down for you. First of all, first option, C-style arrays. If you're writing in the C programming language, you use them. We're not using the C programming language, so do not use ever. There's my advice to you guys. Never use one. Never use one of those. Okay? Simple. Don't use it. Okay? There's legitimately no benefit to using a C-style array. Sometimes there's a benefit to using a C++ style array. Doesn't come up very often, especially not in this class. In this class, vectors, they are the vanilla ice cream. If you don't know what kind of ice cream, you're making a sundae, you know, it's Thanksgiving, you're making a sundae for people, and they haven't told you what kind of ice cream they want. You're not going to like put pumpkin flavored ice cream. You're just going to use vanilla. You know what I mean? Vanilla ice cream is your go-to default flavor, and if people want it to be chocolatey, they'll put some chocolate sauce on it or something. You know what I mean? Like vanilla, it's the default. Like it's your go-to default. You know, it's the default data structure. A data structure is something that holds lots of data. Okay, it's your just go-to. Like if I need to make a, you know, grocery list, I'll make a vector and put stuff into it. It's just like, until proven otherwise, I'm just going to make a vector and just use it, and it's fine, and it's good, and it does what you need, you know, until it doesn't. You know, if you need a vector that's always sorted, you know, okay, well, it doesn't do that, you know, then you take this class. You take CSci 41, you learn about, you know, what you know, I always need my grocery list to be sorted alphabetically. And it seems really inefficient to constantly call sort on the vector over and over again. Is there a better way? Yes, there is. You'll learn about it later in the semester. Unless you need something weird like that, I just use vectors. I use a vector for everything, and until it's too slow. And once it's too slow, then I switch it out with something else. Okay. But it's like my go-to data structure. All right. Now, arrays are stack allocated. And so a C-style array and a C++ style array are... Pumpkin ice cream is definitely a thing. Yeah, sure. You're a vanilla guy, I totally understand. Yeah. C++ array, yeah. C++ array is when you make shaved ice and don't add any flavor and serve it to people. That's... Yeah. Why would you do that? Why? Just drink water. I don't know. Okay. C++ style arrays, they have a niche use. They have a very, you know, I almost never use them, but like there's a small use for them. They're definitely better than the C ones. 100% better than the C ones. C++ ones are just better. But the niche use is that sometimes you want them to be stack allocated instead of heap allocated. Now, what the hell does that mean? The stack is about 100 megabytes on this system. It depends on what computer you're on. So it's kind of small. You're not going to be able to do Photoshop using a stack allocated array. You know what I mean? But if you need just like 5 elements, yeah, I might use a C++ array. Why not? And the reason why it's faster to allocate. It's faster to allocate something off the stack than it is on the heap. So if I have a function call, and the function needs to make like 10 variables, and this function is going to be called millions of times a second, I will probably use this. I will make an array of 10 integers, and the stack allocation will just go bloop, like that, and there you go. Heap allocation, it takes some time, because it actually has to hunt around in memory and find a spot big enough to hold it, and then you allocate it, and then when you leave, it has to deallocate it, which puts it back on the free list. Like there's a lot of, it's not that expensive, but like if you're doing it millions of times a second, you definitely don't want to use a vector. Like, you know, like I said, there are some cases where you want to stack, you know, like 10 variables, who cares? Yeah, I'd use a C++ array. Sure, why not? But, yeah, the heap is bigger. I think it's like 2 gigabytes on our system is the max that I allow. But maybe a little slow to allocate. Yep. So there you go. That's the difference. What's the difference between the C array and the C++ array? All the world. All the world. Okay. Why C arrays suck? 1. No bounds checking. No .at function. Okay? Vectors and arrays can do that. They can bounds check for you. 2. No size information. How big is your array when you pass it to a function? Who knows? You don't know. C++ arrays have a dot size that tells you. C arrays have nothing. You don't know how big it is. Oftentimes you have to pass in another parameter that is the size. That's standard practice for most things. Man, string cat. You typically pass in an array, and you pass in a size, and you hope the size is right. You notice how you have two arrays here, and you're passing in one size. Or even worse, you have two strings here, and you're copying from one to the other, and there's no size information anywhere on it. What happens if this string is smaller than that string? It's going to overwrite memory, right? So, yeah, this is an array of characters, and that's the maximum size, and I hope you got it right, because if you didn't, it's going to be overwriting memory, and you're going to get random crashes, and oh Lord, help you. That function right there, by the way, this function right here, which it copies one string to another string. That's it. It's an array of characters. It copies from one to another. That function right there is responsible for more computer systems being hacked than any other. That thing right there. Okay. In fact, if you use it, it'll warn. You get a warning for using it. Let's see. I should check that before I say it. Nope, no warning. Even worse. Okay. Okay. So it copied from this into this. Now, what if it's not quite big enough? This function doesn't take any size information, right? It just copies. Crash. Buffer overflow detected. Okay. It is ridiculously terrible. The reason why people hate C++, like if you ever, like I had a paper rejected from an academic conference because I wrote a paper on how to make C++ easier for students to understand, which talks about this kind of stuff. And two of the people loved it, and they said we should approve. The third person said, no, you shouldn't teach C++ to new programmers, and rejected my paper. It's because of that stuff. He probably did C++ in the 80s and 90s. It was horrible. Yeah, that kind of stuff was horrible. Yeah. Nowadays, though, we have vectors and arrays. So you're clueless about vectors. Yeah, vec 100 is the size. Yeah, these three lines here are equivalent. All right. So all three of the there's now equivalent. I changed it to 10. Can you see this paper anywhere? No, they rejected it from publication. So I can send it to you if you want. Pissed me off though, because I'm like, yes, I know it can suck. I'm trying to fix that, right? Like, why would you, what? Don't get me started. It was annoying. And he somehow convinced the other two people that it was not suitable for. You shouldn't be teaching C++ in a first semester class. Who does that? It has to be Python or Java. That's the only way things are done. It's so ridiculous. Okay. The trauma is real. Yeah, really. I mean, you know, I still think back on my CSci 40 and 41 class, and I'm like, wow, that was really horrible that they make people work with strings and arrays and things like that. Okay, so was he the king of programming? When you're a peer reviewer, yeah, I mean, you're kind of They're kind of the boss. All right. Okay, so C arrays don't do bounds checking. They don't have a .at function. They don't have a .size function. You don't know how big they are. They decay to a pointer. If you pass them to a function, they turn into a pointer. So they're not even arrays anymore. They're pointers. And so all you know is the beginning of the array. You don't know where the end is. Okay, so yeah, they can't grow. There's that too. So vectors can grow. So for those of you that have never seen vectors before, check this out. If I say vector dot push back 420, 69, then I print out the entire vector. Watch how easy it is to print out a whole vector, which you also can't do sometimes with C arrays. For every integer in the vector, see out the integer. Easy as that. Okay. So it's going to print out 100 zeros. Oh yeah, it also initializes itself. So the vector initializes all the elements to 0 for you. If you want to initialize them to a different value, like negative 50 or something, makes 100 negative 50s. Probably a Rate My Professor user. Rejects it because it mentioned video games. I'm still a little salty about it. He only talks about video games. You know what? You know what? Whoever that was, that's why we're doing Zeta Functions. You want something serious? You are getting math so complicated, not even your professor knows what it does. That's what that... quite legitimately. That's why you guys are not getting a fun first programming assignment. You're getting Zeta Functions. Whatever the hell those things are. Which we'll talk about in a little bit. Analytic number theory, exactly. Whatever the hell that is. So, no video games for you guys. No memes. No, you get the number 5 now. There you go. I'm kidding. Okay, so this is going to make 100 elements in the vector, size negative 50. And then this is going to grow the vector. The vector is actually going to get bigger. Yay, that's cool. That's nice. And it's going to put a 5 at the end of the vector. Okay. And this is how easy it is to print a vector. For each integer in the vector, print out that integer. Easy. Simple, clean, concise. Easy, breezy, beautiful cover girl. All right, so there you go. So you got 100 negative 50s and a 5 at the very end. Okay. Easy, breezy, beautiful color girl. Cover girl. Yeah. If you're gonna make a reference, you shouldn't butcher it, right? Okay. So no brackets on the for loop. Yeah, like same thing. Yeah. Anytime you have an if statement or a while loop or a for loop, if you have a single line of code, the brackets are optional. The brackets are optional because in the language it takes a code block following it. A code block can either be a single statement or it can be a curly brace enclosed set of statements. All right. So another very common thing we do is to make a vector of size 0. So there's no elements in it. You can't do that with an array either. With an array, you have to know in advance how big it is. And that's... Do you think you always know in advance how many tax receipts your user's going to enter? No, you don't. So if you use an array, you have to guess. Like, how many tax receipts do you think somebody's going to... Like, you don't know. For one person, it's going to be 10. Another, it's going to be 10,000. You don't know. With a vector, you just make it of size 0, and then as you input, you... let's leave that in there. Yeah, sure. Okay. All true. Int x equals read. Please enter a tax receipt or something. -1 to quit. This is my read library if you haven't used it before. This is the same thing as doing int x, cout, please enter blah, 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 cn into x, with a little bit of extra spice on it, which I'll talk about in a second. Read a tax receipt. If x is equal to -1, then we quit out of the loop. Otherwise, we add it to the vector. So vector.push back. So if you've never used vectors before, this is how I usually use them. I usually make a vector of size 0. Because I don't know, usually I don't know how big my array has to be. You know, I'm going to be reading from disk. I don't know in advance how big it's going to be, right? So I make a vector of size 0, and then I read from the keyboard, or, you know, in a real program, I read from disk. And I read and I read and I read, and as I read, I just grow the vector. And the vector gets bigger and bigger and bigger. So I just end up copying from the file into the vector. Don't waste memory that way, you know? Usually with arrays, you have to make them too big just in case you need it, right? Because if you run out of room in your array, you're toast. You can't resize it. Vectors can resize. So, so we're pushing back that, and then we're going to print them all out. All right, so let's run this. So I'm going to enter in 1, 5, 7, 9, 10, 420, -1. Okay. So we've got 1, 5, 7, 9, 10, 420. Do you see how easy that is? For those of you that have not used vectors before. Super easy to just read in, quit if, you know, whenever. If you're reading from disk, that's usually going to be if I hit the end of file. If .eof, if I hit the end of file, quit. Otherwise, add it to the vector. And it just copy from disk into a vector. It's very common. Like I said, it's vanilla ice cream. If I want to read from a file into memory, I open it up and I read until I hit the end of the file, and everything I read goes into the vector, and it just bloop. And now my vector is a copy of the disk, and then I can work with stuff in the vector. It is the append function. Yes, it appends a number to the end of the vector. But the big brain notion here is that the vectors can grow, so they can actually increase in size over time. Arrays cannot. Okay. Yeah, that's a good point. Vectors do save you a lot of space. Because like if you have to use an array, like one thing people would do is they would read through the file to see, okay, there's 527 tax receipts in there, and then they would allocate an array of size 527, and then they would go back through it and read it again. You know, and so you have to write all this code. You know, like, okay, let's open it up, and let's close the file, let's reopen it, and new, and then we have to have a delete, and see how easy it is. And that's what galls me, is that modern C++ allows you to write, you know, if I got rid of all these comments, right, and I got rid of all the different alternatives and stuff like that, this is not, you know, this is not a very large program, you know what I mean? Like, you know, it's, right? And this is a program that will, you know, read over and over again, grow an array, and then print out the like it's very easy to write, it's easy to understand. So, yeah, all right, so let's talk about the homework. We got 10 minutes left in class, right? So we're gonna continue our discussion of the review of CSI 40 on Friday, but hopefully the assessment test and what we talked about today kind of open your eyes to modern C++ and why it's nice, like compared to like the nonsense like we had to use. Like I don't know why professors would prefer the old way. Like I don't know. You do you. You know, like everyone's got their own philosophy of teaching. I'm not actually critical. It's just like I feel like for new students, like we should start with the easiest to use stuff. And in CSI 45, I can make them use stircat or whatever. Okay. So let's talk about the homework. So first of all, let's talk about FizzBuzz. It's only a couple points. It's not really supposed to be hard, but what I do want to show you is that when you run it, it should just print all the numbers from 1 to 100 with the fizzes and the buzzes switched out. This is a classic job interview problem. You're supposed to be able to code it live in front of a job interview person, or on Zoom, I guess nowadays, in 15 minutes or less, right? And so when do we get the attendance questions again? Every day after class, there will be an attendance quiz that will be due at the start of the next class. So I'll probably put something up on vectors, I guess. I don't know, it seems like the most important thing we talked about today. And then you just answer it before the next class, and that counts as your attendance. Okay. And the assessment test was your attendance for Monday. So basically, let's say you got this, and you want to know, is my code correct? So there is a program that I've written called Input Tester, and what it does is it runs your program, and it compares it. Diff is a compare program, and it differences it with the correct output. And if they're exactly the same, it prints test passed, good on you, 100%. If you got something wrong, then it'll tell you with a little left arrow what you're outputting and a right arrow what the correct answer was. And so like if you're outputting a 5, it'll have like a little left arrow 5, and it'll have a right arrow saying buzz, right? And you're like, oh, I'm not doing the division by 5 right. Okay. And so it can be a little weird to decipher these things sometimes. Ask on the help channel if you don't understand it. Also, these files here you can open up yourself, so you can actually look at the correct output, right? So you can look at the correct output and see what what it's supposed to be entirely from top to bottom. That's fine. But there's only one test case for FizzBuzz because you just run it. So test passed, 100%. There you go. Even though the assessment quiz says due today, you have until Friday to get 8 out of 8. That is correct. Yeah, I set the deadline as today so that it would count for attendance, but I want all of you to get 8 out of 8. And that's why I set the deadline to Friday. So it'll say late, but you're not going to lose any points or anything on it. Okay. How do you test it again? Just go into the quiz section. You can take it as many times as you want. What about 7.89? If you're fine with the 7.89, it's okay. It's called input tester. Input _ tester. Okay. And then let's talk about the Zeta function. So the Zeta assignment is a thing. Let's see. So a little background. I was up at Shaver, and we were talking about our hardest classes. It's one of my friends she's very smart. She has a master's in computer science. She went to UCSD with me. I don't think we were there at the same time. Maybe she was. I don't know. I think she was a little bit after me. But she said the hardest class she had at UCSD was studying Zeta functions, which is some sort of advanced mathematics that I don't understand. And so I said, all right, so what is a Zeta function? She's like, I don't know. And I'm like, but you took a class on it. She's like, I know. I still don't know what it means. And so I was like, all right, I'm a smart guy. I can figure this out. So I opened up the references on it, and I'm like, all right, let me learn about these things. They can't be that hard, right? They can't possibly be that hard. Yeah, I don't know. Yeah. Riemann's Zeta function is defined by the Dirichlet series, which converges absolutely uniformly in any bounded domain of the complex S-plane, for which sigma is greater than 1 plus whatever the hell that is with that thing over 0 if sigma is over 1. A valid representation is the Euler product. Like, what the hell? I don't know any of this, So I'm like, all right, maybe the Euler product will, reveal things to me. It's the infinite product where S is a real number and P runs through all the prime numbers. This product converges absolutely for all. Like, yeah. So, so I was like, okay, all right, I don't understand any of that. But this thing here, I'm like, okay, I understand this. I can have my students do this. And in fact, I'm having my CSI 45 students do it also as kind of a warm-up exercise at the start of the semester. And I'll see if they can do it. And if they can do it, you can do it, right? So that's how it works. You can still check to see if not seen when using read afterwards. So the killer thing about this thing is that this is not pi, right? Or like it's the pi character, but it's not pi. It's not 3.1415. It has nothing to do with 3.1415. It's terrible. I don't know why math people do this to people, but they're like, all right, we're going to take this really common, really popular symbol that everyone knows what it means. It means 3.1415, and we're going to have it mean something completely different. Because I don't know why, because I got nothing. It's kind of like the number of different meanings E has. Sometimes it's 2.7. Sometimes it's the electron charge. Like, if you just see E, like, you're like, all right, which one is that? I don't know, but pi, like, come on, it's pi. Don't use it for other things. Just leave it as circles and stuff, come on. So, yeah, I'll show you the Zeta program running in a second. What this means, though, is the number of number of pi's, number of primes less than or equal to x. So if I passed in pi of 3, it would return 2, because there's 2 primes less than or equal to 3. There's 2, there's 3. Okay? If I passed in 10, it would return 2, 3, 5, 7. It would return 4. Okay? So the pi function returns the number of prime numbers. And remember, prime numbers does not include 0. It does not include 1. All right? It's 2 is the first prime number. 1 is not. Okay? So the command for compiling is g++. And so what this is doing, like if you pass in 7 for I and 10 for j, it's going to compute the pi of 7 plus the pi of 8 plus the pi of 9 plus the pi of 10. That's the summation character. So the big sigma here means add up the results of the prime counting function from I to j. Okay, so let me snap that over here and pull up my thingy again here. Let me run it for you here. And so the hardest thing in computer science is not really actually learning the language, right? Like, you need to know if statements and for loops and functions and while loops and variables and algebra. That's the basics. And you need to know that really well. That's why I'm giving you the assessment test. Like, you have to have the fundamentals down. But the hard thing in computer science is how do I put them together, right? Because this summation thing here, it's going to sum up. The summation is going to call a function multiple times, and every time you call that function, it's going to count how many primes there is less than or equal to that number. But in order to know if a number is prime, that's also a loop. So it's like a loop within a loop within a loop. So there's like 3 loops, and once you get too many loops, like the human brain goes like, grind, gears start locking up, things like that. That's why I'm using this as a good little introduction programming assignment to kind of get your juices flowing on it. It's not big, like you're just doing that little thing there, but how you structure it in your head, that's computer science, right? And as you develop your skills in computer science, you get the ability to kind of, all that becomes a little bit easier. Okay, let me run it for you. So if I start at 7 and I go to 11, then pi of 7 is 4, right? 2, 3, 5, 7, 4. And then pi of 8 is 4, pi of 9 is 4, pi of 10 is 4, then 11 is the next prime number, so you see it ticks up to 5 there. Okay. And if you add them all together, you get 21, so the answer is 21. So it'll print the results of the function as long as the difference is 10 or less. So if we go from 3 to 13, it'll print all the numbers. If you go from 3 to 14, it only prints the answer. The reason for that is because otherwise you'll be printing out 100,000 numbers. So if the difference between I and j is 10 or less, you print the results of the function. If it's bigger, you just print the sum. Okay. So if we go from 100 to 202, you print it. Go from 100 to 200, you don't. Okay. Now you might be like, won't this be kind of slow? And the answer is yeah. It depends how you implement it. Right? If you have a triply nested for loop, it's probably going to be slow. It's reasonable. So if you run the input tester, you'll see that there's actually 11 test cases, or 12 test cases. The first 10 are reasonable. The last 2 are large. So for input file 11, it's actually going from, that's a large number, huh? It's like, I don't know, 10, 100 billion, I don't know, it's some large number. So have fun. It's computing 100,000 numbers up in the, I don't know, 100 billion range, something like that. I can't count that many zeros. The word pi is not a keyword. If you're no, the let's not show the answer, huh? Fortunately, they didn't have any code there. Main.cc. Pi is not a keyword. MPi is pi, 3.1415. But you should not be using that. There's nothing to do with pi. It is a horrible thing that I don't know why math does this to people. Like literally, like you're just making it harder to understand than it needs to be. You know what I mean? Like if you don't want to write out prime counting function, just call it the PCT. You know, then maybe people who hike on the Pacific Crest Trail will get confused. But like that's a lot less people that'll get confused than the people who think pi means 3.1415. You know what I'm saying? I don't know. Just my own take on it. Okay. Do we need to pass those test cases to get full points? Full points is 10 out of 10. If you get 12 out of 10, you get extra credit. Okay. So there is 120% available on the assignment. So I'm not going to tell you how to optimize it. There is a hints file, and the hints file has some hints in it, as you can imagine. But don't look at that until, don't look at this until you have got it working. Remember, when you code, start safe and slow and just get it working, get it correct. Okay? And then after you get it working, then start thinking about, all right, how can I make this faster? Am I ever redoing any of the calculations? You know, like, is there some redundancy in this that I can remove? Can I make it faster somehow? And the hints file will offer some guidance to ways that you can make your code faster. Will every assignment have extra credit? No. I do offer a lot of extra credit, but it's not every. Like, FizzBuzz doesn't have extra credit. Not everyone. But, yeah, a lot of times I'll do something like this where, like, if you want to go above and beyond, and it's good. It's like a good exercise. Like, okay. You know. Is there a pattern to the sums? I don't think there is. No. Your code will be taking 12 years to run. Nope, the autograder gives you 3 seconds. So you've got to add up the pi of 100 billion to 100 billion and 100,000 in less than 3 seconds. Remember the optimizer. Use ++-03 as your friend. Turn the optimizer on if you're going to be doing this. You know, if you're running out of time, try that first. Yeah, but that's not going to save you. If you got a triply nested for loop, it's going to be too slow. If you're counting from 0 to 100 billion triply, that's not going to happen in 3 seconds. It's not going to happen in 3 years, I don't think. Okay. Will there be creative assignments like RPG 40? Of course. Yeah, absolutely. The only downside to the creative assignments is that they take a while to grade. You know, like when you got 50 RPGs, you have to play 50 RPGs, and that takes a while. And then I go through all the source code. And, you know, and you saw how long it took me to grade it last time. It took like a month or so to grade it. 10 trillion, nice. How do you run test cases with Nano? Nano is a text editor, so Nano is a replacement for Vim. Which you should not use. What you should do is look at Min Curley's video that he made on using Vim and Unix. I know as a student, like anytime the professor says something is optional, you don't do it. But trust me on this, it will save you so much time and maybe the experienced students on here can like chime in. It will save you so much time. Like you're like, I don't have time to watch. It will save you so much time if you watch Min Curly's video on Unix and Vim, and yeah, it has a negative time cost, and it's like half an hour, and he makes meme jokes and things like that. So it's plus you'll make him happy. Make sure you like and subscribe. Slam that alarm bell. Yeah, and yeah, so the input tester again for this is input tester. Right? You're an input tester, it'll tell you if you're getting it right or wrong. So let's see if Hazelton did it. Become Hazelton CD. What shell are you using? Bash. That's fair. Yep. So Hazelton passed them all. Good. Good. He's a graduate of the program, so good. It was fun though, right? Was it fun to solve the Hazelton? Was it fun to solve the puzzle? Because I feel like it's a fun assignment. Helped you get back into some C++ magic. Yeah. Now let's see his code. Nah. let's just word count it. 83 lines of code. All right, that's fair. 67. Yeah. So it's not even that big a program. It's like a page or so. Got a week. You got a week from today to do it. Okay. Brofist the like button. You can't tell if my input tester is working properly. Could you input test FizzBuzz? Sure. Tom Lopez. Yeah, your code's wrong. So you're outputting FizzBuzz and Fizz, and it should be capitalized, I guess. So this means you have an extra FizzBuzz. So I'm just gonna guess that your for loop is starting at 0. You don't want to take that bet? Buy me some popcorn. Oh yeah, and if you guys are getting this error message with Vim, edit your vimrc file, and at the very bottom there's 3 lines of code. Delete those 3 lines of code. I have Solarized installed on my Vim. You don't, and I pushed out a copy of my Vim RC to all of you guys. So, yeah, there it is, right there. Okay. So FizzBuzz starts at 1, not at 0. Okay. So that was one of your problems, and the other one, see that? The left arrow is your code, the right arrow is my codes, because there's no right arrow. That means you have an extra FizzBuzz. And then all the other things I think are just capitalization mostly. You're outputting a lowercase f, it's supposed to be an uppercase f. Lowercase, yeah. I think once you fix the capitalization, you should be fine. I think. No, maybe. That might be wrong too. I don't know. Okay. So that's the input tester. It's very useful. Very useful. Your code's only 54. Oh, really? Really, we're doing this. We're doing this. We're gonna compare our compare size. To be fair, I did it first. Okay. Main.cc. All right. 100 Shift J. There it is. It's all one line of code. I joined the whole thing onto a single line. Yeah, that's fine. There. How do you get rid of the error message? You're going to vim your vimrc like that. Vimrc is the configuration file for Vim. And at the very bottom of the file, you get to the very bottom by hitting Shift G. And then delete the bottom 3 lines. DD, 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 or D3D. And it'll get rid of the bottom 3 lines, and that is the I'll just paste that onto Discord for you. Is the problem. Some students asked for a copy of my vimrc, and yeah, it slipped my mind that you wouldn't have Solarized installed. Solarized is the color scheme. So Kohler is what I use by default. Solarized is almost identical to color scheme Kohler. If you look at the gray on Kohler, it's white, and so it hurts your eyes a little more. So I like solarized. It's a little easier on the eyes. The whites turn into a slightly darker gray. Cool. You got it all right? Awesome. Well done, Mr. Lopez. All right. So that is it for today. Thanks for coming out, everyone. We went 10 minutes over, but hopefully you're all right with that. And so then on Friday, we're going to basically just go over all of C++ and take it from the top to the bottom. We're going to go over all of C 40 on Friday. And then we'll see where you're at after that. Okay? So keep taking the assessment test. If you haven't gotten 8 out of 8 yet, get yourself up to 100%. And work on FizzBuzz and work on Zeta. And then I'll see you guys on Friday. All right. Peace out. Bye. Be sure to like and subscribe.